Now, let me discuss the principle of order crossover. Now, this order crossover is one of the most popular crossover operators used in scheduling GA. Now, I am just going to discuss the principle of this order crossover, how to find out two children solution from the two parents. Now, the concept was proposed by Davis in the year 1985. Now, supposing that I am solving a scheduling problem, say one TSP problem, traveling salesperson problem involving say 9 cities. That means, a person will have to touch all n cities once by covering the minimum distance, and supposing that, so we have created the initial population from the GA at random and using the reproduction operator. So, we have selected the mating pool, and these two parents are going to participate in crossover. Now, the parent 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, and parent 2 is 3, 4, 5, 1, 2, 9, 8, 7, 6. Now, let us see how to get the two children solution from these two parents using the principle of the order crossover. Now, the principle is very simple. Now, what I am going to do? I am just going to find out the two children solution. Now, what I do is, say let me write here child 1. Now, to get the child 1, the first thing you will have to do is, you will have to select the two crossover sites at random. So, this is the first crossover site, second crossover site, and the cities which are lying in between these two crossover sites, first we will have to concentrate on that. Now, what I do is, now here within these two crossover sites on parent 2, these cities are lying like 1, 2, 9, 8. So, what we do? First we locate 9 just position 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this 1, 2, 9, 8 I am just going to directly copy from parent 2, keeping their position intact. Like I will start from the 4th position. So, this is the 4th position. So, let me write here 1, 2, 9 and 8 here. Now, after I selected 4 cities from parent 2, what we do is, we concentrate on the first city after the second crossover site lying on parent 1. The first city after the second crossover site lying on parent 1 is nothing but your city 8. Now, if I see the city 8 has already come, so I am not going to take it once again. Next, I go to city 9. Now, city 9 is already there, so I cannot take it again. Next, we continue our search in this particular direction. So, I will come back to the leftmost city lying on parent 1, that is 1 is also lying here. So, I cannot take. The next is city 2, 2 is already there. So, I cannot take. The next is your city 3, 3 is not there. So, I can select city 3 here. The next is city 4, 4 is also not here. So, let me select city 4 here. So, city 4 here. The next is city 5. Now, city 5 is actually is not yet copied here. So, I can put it here. Now, then comes your city 6, city 6. Now, city 6 is once again not here. So, let me put city 6 here, and next is city 7. Now, 7 is also not here. So, let me put 7 here. Now, this completes the child 1. Now, let me just try to check whether I have considered all the cities once. City 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the cities have been considered once, and there is no missing city here. So, this is a valid child. So, this is the child 1. Now, let us see how to find out the child 2. Now, to find out the child 2, once again let me first locate the 9 positions 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what we do is the cities which are lying between the two crossover sites on parent 1, that is your 4, 5, 6, 7. So, those things are directly copied, keeping their position information intact. So, what we do is we copy 4 here, then comes 5 here, 6 here and 7 here, and now I concentrate on the first city after the second crossover site, which is lying on parent 2, and that is nothing but city 7. Now, city 7 is actually already copied here. So, I do not want to copy once again. So, next I go for city 6, 6 is also already there. So, I cannot copy it again. Then I go to the starting of parent 2. Now, at the starting of parent 2, you have got city 3, 3 is not here. So, I can copy 3 here. The next is city 4, 4 is already there. So, I cannot copy it again. The next is 5, 5 is already there. So, I cannot copy it again. The next is city 1. So, 1 is not here. So, let me put 1 here. The next is city 2, 2 is also not there. So, let me put 2 here. Next is city 9. So, 9 is also not there. So, let me put 9 here. Then comes city 8, 8 is also not here. So, let me put city 8 here. Now, with this I complete actually the child 2. Now, let me check whether all the cities have been considered once or not. Now, city 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the cities have been considered once. So, this is a valid child. So, using the principle of this order crossover, actually we can find out 2 valid children starting from the 2 parents. Now, whatever I have discussed, the method which I have discussed, the same thing actually I have written it here. Let me have a quick look. Now, the procedure is as follows. We select 2 crossover sites at random, which I have already discussed. To obtain child 1, the elements 1, 2, 9, 8 lying between the 2 crossover sites are directly copied from parent 2, keeping their location and order intact. This I have already discussed actually in the last slide. So, to get this child 1, we first copy with this particular 1, 2, 9, 8, and then we concentrate here. Now, let us see that particular the method. Child 1 2 then begins from parent 1, starting from the first position after the second crossover site and searching towards the initial elements of parent 1, and this process will go on and go on till I select all the cities once, and the same procedure is followed to get this particular the child 2. So, using this particular the crossover operator, the order crossover operator, we can find out 2 valid children starting from the 2 parents. Now, let me do one thing. Let me take another example just to show you the principle once again. Now, what I do is, so I am going to take another example, the similar type of example. Say, let me consider one TSP involving say 8 cities. So, I am solving another example. So, supposing that the parent 1 is something like this 1, 2, 3, 4, 5, 6, 7, 8. So, it is having 8 cities, and parent 2 is nothing but say 6, 5, 4, 8, 3, 7, 2, 1. So, these 2 parents are going to participate in order crossover, and let us see how to find out the children solution. So, I am redoing this particular example. Now, supposing that the first crossover site is here, which is selected at random. The second crossover site is here, which is also selected at random, and I am just going to find out the child 1. So, once again let me locate 8 position 1, 2, 3, 4, 5, 6, 7, 8. Now, what I do is, so to get child 1, so these cities are copied first, keeping their position information intact. So, 4, 8, 3, 7. Next I concentrate here. So, here we have got 7, 7 is already copied. Next is 8, 8 is also copied. So, you come back. Next is 1, so I put 1 here. Next is 2, so I put 2 here. Next is 3, 3 is already there. Next is 4, 4 is also already there. Next is 5, 5 is not there. So, let me put 5 here. Next is 6, 6 is not there. So, let me put 6 here. This completes child 1. Now, similarly, I can find out the child 2 also. So, 1, 2, 3, 4, 5, 6, 7, 8, 8 position let me locate. Now, to get child 1, so these cities I copy first, like your 3, 4, 5, 6. Now, I concentrate here. So, it is 2, 2 is not there. So, let me copy 2 here. Next is 1, 1 is not there. So, let me put 1 here. Next, I start from here. Now, here actually we have got 6, 6 is already there. Next is 5, 5 is also there. Next is 4, 4 is also there. Next is 8, 8 is not there. So, let me put 8 here. The next is 3, 3 is already there. Next is 7. So, 7 I can put here. So, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So, both the children are the valid children. So, starting from these two parents using the principle of order crossover, so we can find out the children solution very easily using this particular the principle. Now, I am just going to start with another very popular crossover operator, that is called the cycle crossover. Now, the idea of this particular cycle crossover that was introduced by Oliver et al. In the year 1987. Now, here actually what we do is, we start with a particular point, a particular city lying on the parents. Now, supposing that, so these two parents are going to participate in cycle crossover. So, the parent 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So, this is once again a TSP involving 9 cities, and the parent 2 is 3, 4, 5, 1, 2, 9, 8, 7, 6. Now, let us see using the principle of cycle crossover. So, how to find out the children solution. Now, what we do is, so we first select the starting point of the cycle at random. So, I have got 9 locations. So, out of 9 any one I can select as the starting city, and here, so at random I have selected, so the third position as the starting. Now, using these particular parents, parent 1 and parent 2, let us see how to find out child 1 and child 2. So, let me write here child 1, but before that the 9 position let me locate 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, here actually what we do is, we start from this particular the location. So, that is the third location. So, to get the child 1, what we do is, we start with the city 3, which is lying at the third position of parent 1. So, let me put the city 3 here at the third position, and once I put the city 3 at third position, now I will try to find out the location of city 3 on parent 2. Now, this is the location of city 3 on parent 2, that is the first location, and the city corresponding to location 1 lying on parent 1 is nothing but city 1. So, what I do is, so at this particular position, so I put city 1 here. The next, once I have copied 1 here, I will try to find out the position of city 1 on parent 2. So, this is the position, and at this particular position the city lying on parent 1 is 4. So, what I do is, So, here I am just going to put 4, and once I have copied 4, next I try to find out the location of city 4 on parent 2. So, this is the location and its corresponding city is city 2. So, let me put city 2 here, and once I have selected city 2, so what I do is I try to find out the position of city 2 on parent 2. So, this is the position and its corresponding city lying on parent 1 is 5. So, let me put 5 here, and once I have selected 5, I try to find out the position of city 5 on parent 2. So, this is the position and it corresponds to city 3 lying on parent 1, but 3 I have already considered. So, that completes this particular the cycle. Now, you see, so till now I have taken 5 cities for child 1, 1, 2, 3, 4, 5, and all 5 cities have been taken from this particular your parent 1. And till now I have not considered anything from the parent 2. Now, what I do is the remaining thing I just copy from the parent 2, that is 9, 8, 7, 6. So, let me put here 9, 8, 7, 6. Now, let me check. So, city 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the cities I have considered once and there is no missing city, there is no repetition. So, this is a valid child 1. Now, following the same principle, actually I am just going to show how to find out the child 2. So, child 2, let me first locate the 9 location 1, 2, 3, 4, 5, 6, 7, 8, 9, and let me once again concentrate on this star position, that is the starting of the cycle, and let me concentrate on your this 5. So, at this particular starting position I have got city 5 on parent 2. So, let me start with that. So, if I start with city 5 at third position, so let me put city 5 here, and once I have selected city 5, I will try to find out the position of city 5 on parent 1. So, this is the position of city 5 on parent 1, and at this particular position, its corresponding city is city 2. So, what I do is the fifth position. So, 1, 2, 3, 4, 5. So, fifth position I am going to put 2. Now, once I have selected 2, I try to find out the possible location of city 2 on parent 1. This is this particular position, that is the second position, and at the second position the corresponding city lying on parent 2 is 4. So, what we do is at the second position we put city 4, and once I have selected 4, so I just try to find out the position of city 4 on parent 1. So, this is the position and its corresponding city on parent 2 is 1. So, at fourth position I will have to put city 1. Now, once I have selected 1, I will try to locate the position of city 1 on parent 1. So, this is the position, that is the first position, and its corresponding city lying on parent 2 is your city 3. So, at the first position I am just going to put city 3, and once I have selected 3, now I am just going to mark city 3 on parent 1 and its corresponding city is 5, which I have already taken. That completes actually this particular the cycle, and you see all the cities till now on child 2 I have selected from the parent 2, like 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, and till now I have not selected anything from parent 1. So, the remaining vacant positions should be filled up from this particular the parent 1, that is this particular city should come here 6, 7, 8, 9. So, let me write here 6, 7, 8, 9, and now let me check whether I have considered all the cities or not, and a particular city should not repeat and there should not be any missing city. So, let me check city 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the cities have been considered 1. So, this is a valid child. So, using the principle of this particular the cycle crossover, so we can find out two valid children starting from the two parents. Now, before I just proceed to the next, let me whatever I discuss, let me just show you the way I have written it here. The procedure to determine child 1, select a parent, say parent 1, and the starting position of the cycle, say third at random. So, child 1 third position is nothing but 3, the way I discussed a few minutes ago. Okay, so, this was actually the starting for the child 1. The next is actually PR2 is then checked to check the presence of element 3, and it has been found in the first position. So, what we do is, so this particular the 3 we try to find out the possible location of 3 on parent 2. So, this is the location, and corresponding to this particular location I have CT1 on parent 1. So, that has been copied, and this particular procedure has been repeated. Okay. So, this is the way actually we can find out the two children solutions from the two parents. Now, let me do one thing. Let me try to solve another numerical example, and let me just try to do one thing. So, let me consider another numerical example, and to solve it, let me do one thing. The same parent I will consider. The only thing I will do is I am just going to change the starting position of this particular the city. Now, if I consider the same one, and if I just consider the starting, supposing that I am just going to consider, so this is the starting position instead of this. So, this is my starting position, that is the sixth position. Sixth position is the starting position. So, this is not the starting position now. Now, let us see how to find out the children solution. So, once again I am just going to use the cycle crossover just to solve this problem by making a little bit of change in the starting position of the cycle. Now, if this is the starting position, that is the sixth position from the left, let us try to find out the child solution. So, child 1, once again 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let us see the sixth position, I should copy 6, 1, 2, 3, 4, 5, 6. So, I am writing 6 here, and now I try to find out the possible location of 6 on parent 2. So, this is the location, and its corresponding city is 9. So, I am just going to put 9 here. Now, I try to find out the location of city 9 on parent 2. So, this is the location, and its corresponding city is city 6. 6 I have already considered. So, that completes the cycle, and once you have completed the cycle, so rest of the thing I will have to take from the parent 2. These two I have taken from parent 1. So, if I took the other things from parent 2, so I will have to write 3. So, this 3, then 4, then comes your 5, then 1, then comes 2, 2 I have copied. Okay. Now, you see here I have got, so this I have already, this position is filled up. So, 8, 7. So, I will have to put 8 and 7, and let me check city 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the 9 cities have come only once, there is no missing city, there is no repetition. So, this is nothing but a valid child, and following the same principle I can also find out the child 2, child 2. So, once again 9 position 1, 2, 3, 4, 5, 6, 7, 8, 9, and let me put. So, this particular the starting one on parent 2 is 9. So, let me put the 9 here at the 6th position 1, 2, 3, 4, 5, 6. So, let me put 9 here, and once you have got this particular 9, I try to find out the possible location of city 9 on parent 1. So, this is the location, and its corresponding city is city 6. So, let me put city 6 here. Now, once I have selected 6, now I try to find out the location of 6 on parent 1. So, this is the location and its corresponding city is 9, 9 has been considered. So, that completes the cycle and the remaining vacant position are to be filled up from this particular the parent 1. Now, if I take the city 1 will come here, then 2 will come here, then comes 3, then comes your 4, then comes 5, this is filled up, then 7, 8, 7, 8. Now, let me check 1, 2, 3, 4, then comes 5, 6, 7, 8, 9. So, all the cities have come. So, this is actually a valid child, that is child 2. So, starting from 2 parents, how to find out the children solution using cycle crossover, I have discussed with the help of 2 examples. Now, I am just going to start with another crossover operator, that is called the position based crossover. Now, this particular concept was proposed in the year 1991 by Sisbarda. Now, here actually the principle is something like this. We select a few positions using the random number generator at random. Now, supposing that we have got parent 1 like 1, 2, 3, 4, 5, 6, 7, 8, 9 and parent 2 3, 4, 5, 1, 2, 9, 8, 7, 6. Now, these 2 parents are going to participate in position based crossover. Now, let us see how to get the children solution. Now, to get this particular children solution, what we do is we select this position at random and here I have selected only 4 position like the first position, the 4th position, 7th position and the 9th position at random. I can also select 3 position or 5 position at random. Okay. Now, here I have selected 4 position. Now, let us see how to find out child 1 and child 2. Now, child 1, now first I locate 9 position 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what you do is you concentrate on parent 1. Now, to get this child 1, the star position of parent 1 should be copied first. So, this will be copied at location 1, then 4 will be copied at location 4, then 7 will be copied at location 7 and this 9 will be copied at the 9th position. Now, what you do is, so all such things have been taken from parent 1. Now, I will have to take something from parent 2 and what we do? We concentrate here. Now, if I concentrate here, the first is city 3, 3 is not considered. So, this is the first vacant position counting from the leftmost side. So, 3 should come here. Next is city 4, 4 is already there. So, I cannot copy it again. Next is 5, 5 is not here. So, let me write 5 here. Next is 1, 1 is already there. Next is 2, 2 let me put 2 here. Next is 9, 9 is already there. Next is 8, 8 is not there. So, let me put 8 here. Next is 7, 7 is already there. So, next is 6, 6 is not there. So, I can write 6 here. So, let me check whether all the cities have come once or not. City 1, 2, 3, 4, 5, 6, 7, 8, 9. So, this is a valid child. Similarly, I can find out the child 2 also. Now, let me locate 1, 2, 3, 4, 5, 6, 7, 8, 9 position. Now, let us concentrate on parent 2. So, this is the star position, this is the star position, the star position and the star position. So, the star position I should copy first. At the first position I have got city 3, then at the 4th position I have got city 1, then at the 7th position I have got 8. So, So, I have got 8 here, and at the 9th position I have got 6. Now, all such things are taken from parent 2, like 3, 1, 8, 6 are taken from parent 2. Now, I concentrate on parent 1. Now, here at the first position we have got 1, CT1 I have already taken. So, I cannot retake. Then CT2, 2 is not there. So, I can select 2. Next is 3, 3 is already there. So, I cannot take 4, 4 is not here. So, let me take 4 here. Next is 5, 5 is also not here. So, let me put 5 here. Next is 6, 6 is already there. Then comes your 7. Now, 7 is not here. So, let me put 7 here. Next is 8, 8 is already there. Next is 9. So, let me put 9 here. And now, let me check whether I have considered all the cities only once. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, this is actually a valid child, and using the principle of this position based crossover. So, we can find out 2 valid children starting from the 2 parents. Now, so this particular principle, let me try to explain once again, but before that let me the principle which I discussed. So, let me read it from the slide little bit just to show you the principle. To determine child 1, choose a number of crossover points, say 1st, 4th, 7th and 9th on parent 1. So, this I have already done. The elements 1, 4, 7 and 9 are directly copied from parent 1. So, this I have already copied from parent 1 by keeping their position information intact to child 1. So, we get a few cities copied in child 1, and the remaining cities we will have to take from the parent 2. So, which I have already discussed. Now, what I am going to do is the same numerical example, I am just going to change the positions at random, and let us see how can we solve it. Now, let me remove this particular position whatever I consider previously. So, this is removed, this is removed, the star position is removed, the star position is removed, and let me reposition the star. Okay. So, let me put one star here at the 2nd position, let me put one star here at the 5th position, and let me put one star here at the 8th position. So, previously consider the star position I am removing, and now I am just putting star here at the 2nd position, the 5th position and the 8th position, and let us see how to find out the children solution from the same 2 parents. Now, if I want to find out child 1, once again first I locate the 9th position, 4th, 5th, 6th, 7th, 8th, 9th. Second position I have got 2. So, let me put 2 here. The 5th position I have got 5. So, I have got 5 here, and the 8th position I have got 8. Okay. Now, I will start from the starting city, that is the leftmost city lying on parent 2. So, the first one is city 3, 3 is not considered. So, let me put 3 here. Next is 4, 4 is not considered. So, let me put 4 here. Next is 5, 5 is already considered. So, I cannot retake. Next is 1. Now, 1 is not here. So, let me put 1 here. The next is 2, 2 is already there. So, I cannot take. Next is city 9, 9 is not there. So, let me put 9 here. Next is 8, 8 is already there. Next is 7. So, 7 is not here. So, let me put 7, and the last is 6. So, let me put 6 here. Now, you see 1, 2, 3, 4, 5, 6, 7, 8, 9. So, this is a valid child. Now, if you compare the child 1 which I got earlier and this particular child 1, they are different, because we have changed the star position. Now, similarly, we can find out this child 2, and once again 9 position, let me locate 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, the star position we will have to copy first from parent 2, that is the second position, then comes the fifth position and the eighth position. The second position let me put 4 here, the fifth position let me put 2 here, 2 here, and the eighth position let me put 7 here. And now, I will start my search from parent 1. So, the first is city 1, 1 is not considered. So, let me put 1 here. Next is 2, 2 is considered already. So, I cannot retake. Then city 3, 3 is not here. So, let me put 3 here. Then comes 4, 4 is already there. So, I cannot retake. Next is 5. So, let me put 5 here. Next is 6. So, let me put 6 here. Next is 7, 7 is already taken. Next is 8. So, 8 is not here. So, let me put 8 here. Next is 9. So, let me put 9 here. Now, let me check city 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the cities have been considered 1. So, this is actually a valid child. So, starting from the 2 parents, so we can find out the valid children solution using the principle of this position based crossover. And here I have solved 2 examples, and you can see that on example 1 and example 2, the children solutions which we got, even considering the same set of parents, are different. The reason is the star position. Previously, I consider 4 star position, and in the second example, I consider only 3 star position, and I am getting the different children solution. So, this is the way actually we can find out the children solution from the 2 parents. Thank you.